Hi guys, this video is on solving quadratic equations using completing the square, which is the third method that we have looked at in our class. We've looked at factoring and the quadratic formula, and now we're going to use completing the square. They are all different alternatives to do the same thing, but some of them tell you some different things, and we'll look at that here in this video. So, the first thing we're going to talk about is the square root property, and that is if b is a real number and a is equal to b squared, then a equals plus or minus the square root of b. It's actually plus and minus the square root of b. So for instance, example that we have here, x squared is equal to 15. That means x is equal to the positive square root of 15 and the negative square root of 15. So these examples here are set up for you and they're worked out. So the first thing you want to do is isolate the variable. In a, it's already isolated. So when you square root both sides, you get plus or minus 5 because the square root of 25 is 5. On number 2, you have to isolate the variable first. So we're going to divide both sides by 2 and get x squared equals 7. Then when you take the square root of both sides, you get x is equal to plus or minus the square root of 7 because it doesn't simplify at all. On C, we have our first squared binomial, and you see there's no coefficient in front of it. So we are going to just take the square root of both sides. So x plus 1 is equal to plus or minus the square root of 12. Then we still have to isolate the variable, so we're going to subtract 1 from both sides. So we get x is equal to negative 1 plus or minus the square root of 12, which simplifies into 2 square roots of 3. On our next example with another binomial, we have the binomial 2x minus 5 squared is equal to negative 16. So when you take the square root of both sides, you're going to get 2x minus 5 is equal to plus or minus the square root of negative 16, which is 4i. Then we're still going to continue isolating our variable. We're going to do that by adding 5 to both sides. So 2x is equal to 5 plus or minus 4i, and then we're going to divide everything by 2. So we will get x is equal to 5 plus or minus 4i over 2. So these next two examples are set up for you to try. We are going to talk about the answers on the next screen, but I would like you to pause and work these out on your own if possible. So when we look at these, on A, you should have gotten plus or minus 2. When you divide both sides by 5 to isolate your variable, you get x squared is equal to 4. You take the square root of both sides, so x is equal to plus or minus 2. On B, we have our binomial square. We have x minus 3 squared equals 9. When you take the square root of both sides, you get x minus 3 is equal to plus or minus 3 because that's the square root of 9. And then we're going to add the 3 from the x plus 3 side over. And here, since we only have numbers, we can work these out. So 3 plus 3 is 6, and 3 minus 3 is 0. So 6 and 0 are our actual answers. We also want to talk about factoring. And when we look at these factor examples, they are perfect squares. So when we factor them, we're going to get x plus 1 times x plus 1, which is the same as x plus 1 squared. On the second example, x squared minus 6x plus 9, that's going to be equivalent to x minus 3 times x minus 3, which is x minus 3 squared. So your example's already done here, x minus 2 squared. On the next three examples, these are actually problems where the perfect square is set up already on the side, but you have to factor it. So x squared minus 2x plus 1 factors into x minus 1 squared. It's equal to 25. So to solve these, we just practiced that. We're going to take the square root of both sides. So we get x minus 1 is equal to plus or minus 5. So then we add 1 to both sides, and we get x is equal to 1 plus or minus 5, which means x is equal to 6 and x is equal to negative 4. On the second example, We have x squared plus 4x plus 4 equals 9. Again, x squared plus 4x plus 4 is a perfect square. And so when we look at it, we can factor it into x plus 2 squared equals 9. Take the square root of both sides and get x plus 2 equals plus or minus 3. And then subtract the 2 from both sides, so you get negative 2 plus or minus 3. When you work that out, you get 1 or negative 5. So for your turn here, it's already done again. When you factor it into x minus 3 squared equals 16, you take the square root of both sides, so x minus 3 equals plus or minus 4. You add the 3 to both sides, so you get 3 plus or minus 4. Well, 3 plus 4 is 7. 3 minus 4 is negative 1. So those are your answers. All right, so moving along to actually completing the square. So to complete the square of x squared plus bx, you're going to add b divided by 2 squared. So what that looks like with the numbers, if you have x squared plus 6, you're going to take the b value, which is the 6, and divide it by 2. And that's what you're going to add squared to the end. So here you have the 6 divided by 2 squared. Well, 6 divided by 2 is actually 3. 3 squared is 9. So it is x plus 3 squared. And this is it written in algebraic terms, if that helps you. So in A, we're going to take the 2 and divide it by 2. 2 divided by 2 is 1. 1 squared is 1, so we're going to add 1. You're always going to add this last term. On B, we have a b value of negative 8, so we're going to divide it by 2 and get negative 4. Negative 4 squared is positive 16. That's why we're always going to add. On C, it's a little more complicated because 5 is not an even number, so it's not divisible by 2. But that's okay. You're going to leave it as a fraction, 5 over 2, and then you're going to square it. When you square a fraction, you square the numerator, you square the denominator. 5 squared is 25, and 2 squared is 4, so we're going to add 25 over 4. So if you can work out the last example, then you should be adding 25. 10 divided by 2 is negative 5. Negative 5 squared is 25.